introduction, and thanks for organizing this. It's great to be here again. Thanks everyone for coming. It's great to tell you about mathlib. So I saw that you, Manuel, had on your last slide, Lean is not the only game in town. This is right, but perhaps we can learn from each other. So today I'm going to tell you some of the things that we learned in the Lean community that you might find useful. So what are we talking about? Oh yeah, so you have two graphs here. So on the left, you have the number of files, of Lean modules in mathlib over time. So in blue, that is the version of mathlib for the Lean 3 version, and red, that's for the Lean 4 version. So at some point, mathlib got ported from Lean 3 to Lean 4. That's roughly where the blue curve stays constant and the two curves intersect. Yeah, I clipped off the units here, sorry for that, but basically each line here is 1,000 files. So you can see that at the moment, mathlib has about 7,000 Lean files. In terms of lines of code, we're at 2 million lines of code. I checked yesterday, now it finally rounds to 2.0 million. So not that large yet, but it's getting better every day. And on the right here, we see there's also a number of lines in mathlib 4. But we also see a second thing, is namely that code gets continually maintained, it gets modified. You can't just write a proof and then never touch it again, but you will refactor it, perhaps make it more general, perhaps rename it or improve some comments and so on. So there is really constant maintenance going on. And I'll talk about that later, but this is really important. So what does it mean in practice? Well, as a user, this means the worst thing of all things, change. If you use mathlib to prove some other theorem and use it as a dependent project, and you upgrade your version of mathlib, you might have to adapt to changes. No matter if you're using it in industry or you're just using it to prove your fancy theorem that is not in mathlib yet. And such change could be lemmas that get renamed, or perhaps imports to a file change, or perhaps proof breaks because the tactic got more powerful. All of these do happen. If you're maintaining mathlib, then you also have to deal with change because all in-flight contributions need to change, and well, you need to adapt mathlib to changes. But you also have all the issues you get with scaling. Like you need to deal with technical debt. A bit of technical debt keeps you moving fast. It's like, while going into debt in the banking system, like it keeps the system going, it makes it fluid to some extent, but too much of it will slow down your system and bring everything to a halt. You need to keep performance at least bearable. Otherwise, if a system takes too long to be usable, nobody wants to work with it. And you don't have to, but you do want to invest all the time you have into catching systemic issues at the systemic level as opposed to manually. So in Lean 3, there were some linters for type class issues, for example, that apparently were really great at keeping the world from exploding. They have been incorporated into Lean 4 now, so we don't need these particular linters anymore. But for other systemic patterns, you do want to have linters to check. And the big elephant in the room is reviewing contributions. That's what I'm talking about here. So at the moment, there's 2,000 open pull requests in mathlib. Not just 3 a week, more like 30 a day. So yeah, have fun. So I should perhaps, when I say reviewing, talk about what we mean here in mathlib, because that's different from what the MML does or what Isabel does. So in mathlib, we really have one integrated monolithic library. So the point is that code gets moved to the right places, that things are proven in the appropriate generality, that things are only proven once and not twice. So you do want to make sure that when new code is merged, the quality is good enough and that it's compatible with the remaining library. So there is linting to catch mechanical issues. There are perhaps issues with code formatting, but the major part of the review is looking, is the code quality good enough? Is the approach of formalization good enough? And that, well, not surprisingly, is more work than just running a linter and then doing a manual spot check that the high level things are fine. Oh yeah, so how do you deal with these issues? I mean, we can just invest more manual labor, but computers are really good at automating things. So perhaps let's save manual labor when we can and build tooling. So I'm going to tell you what can tooling do for you if you're using mathlib, if you're contributing to mathlib, if you're a reviewer, or if you're a maintainer. And I should say, I mean, none of this is my own work. There's many contributors, but let me specifically highlight Johan, Damiano, and Brian, without whose work I wouldn't be standing here. So what can you do to deal with renamed lemmas? So the good news is so dealing with breaking changes in general can be arbitrarily complicated. But in practice, most of these changes are very easy. Perhaps a lemma gets renamed, and what you can then do is add a deprecation. So you add a marker, this lemma was renamed to that lemma on this date. So when you use the old lemma, then Lean will not just error and say, well, help, I can't do anything. Fix the proof, please, before I can continue. But it will tell you, you used the deprecated lemma and has been renamed in favor of that lemma. And if it's just a name change and other changes, compilation at least will proceed further and just go with a warning. So there is a way to deal with it gracefully. Deprecations are kept around for at least half a year, so you also have time to upgrade if you're in a project depending on mathlib. If you move or rename files, we have a similar annotation, but just for the Lean modules that get deprecated. If you just split up a file or perhaps adjust imports, then that is a thing you currently have to do manually. But luckily, that's a, let's say, 30-second job here. Replace your fine-grained imports by a coarse-grained import mathlib at the top of your file, then run a command to re-minimize your imports, except what it suggests, and usually you're good. So all of these are currently tools that tell you what to do, but they don't do it for you. But that can be automated, and there's a prototype for that already. So if you're using Lean and you realize that is a big bottleneck, talk to us. I mean, I would love to make that an official tool. There's just so many things to do. And it's never clear what of these should be prioritized the most. So what can you do as a user? So let me perhaps switch to something less expected. Finding lemma. So there's this find facts thing in Isabelle, and well, there are similar tools in Lean, and perhaps a few others. So the first one is that Lean mathlib lemmas have a strict naming convention. I use that to search for theorem names, and often you just there, or you perhaps can even guess the theorem name exactly. The lemma finding tactics that tell you, if you think this should be an existing lemma, well, there's a tactic that can tell you, okay, this is an instance of this more general lemma, or I can apply this lemma and then I only have some side conditions to check. Or perhaps I can rewrite by no inequality lemma here and I progress. There's Lugal, written by Joachim Breitner, that does suggest structured theorem search. So if you want to know a theorem that somehow mentions continuity and the sign function, and you know you could search for all theorems that do that. Then you get a list of them, and perhaps your theorem is already there. Otherwise, you can well refine your search and perhaps find the result you want. That is really useful if you know how to formalize the result you want in Lean and a mathlib language. Sometimes you don't know yet. Perhaps it's a different area, and I know, okay, I want to talk about the rank of the module, but perhaps there are 3 different kinds of rank that are closely related but not equal, so I don't know what the right mathlib version is. Then some natural language search is what you want, and those also exist. So if you want to find lemmas, Lean is good for you. But of course, it's even better if you don't need to find lemmas. Heather Macbeth is quoted as, if you need to remember lemma name, something went wrong, you should have a tactic for that. So yes, we should have more Lean tactics. Because Lean is dependently typed, it's harder to just write tactics than in Isabelle. But we're getting there and things are improving. So let me highlight some of my favorite tactics. So I guess one of my favorite tactics is funprop, which can do things like, this function is a composition of 2 continuous functions, hence it's continuous and therefore measurable. Or there's the grind tactic, which is really new, really shiny, and getting better every day, that somehow does all the low-level stuff you don't want to think about. So its scope is it's perhaps as fuzzy as I make it sound, but that might be a good thing if you just, well, want to do the obvious thing and then perhaps tell me what kind of obvious things you had to do. So I personally am very excited to see how grind will get better and mathlib will get shorter as a result. So let me dive one level deeper and go into tooling for mathlib contributions, and perhaps look at the more subtle aspects first. So mathlib is an open source project on GitHub. So you do have many of the standard benefits already, like work happens in public so other people can see it. There's also a Zulip instance, so you can collaborate live. For me personally, coming to the Lean community meant my way of working changed completely from going to a conference where you talk to people twice a year and perhaps there's 5 people in the world who care about your result, I can understand it too. We have this live collaboration instance where there's several hundred people online at the same time, and there's usually lots of people who care about my result, even in the sense of comparison. I'm happy that you formalized something because we have this shared goal of formalizing mathematics. So I think this live collaboration thing gets undersold massively. For me, that is a massive game changer. Like, we have a welcoming community. I mean, I think all of formalization has diversity issues. Looking at the room, I mean, it doesn't appear to be gender balanced. But I think there is a lot that the Lean community that does right, be it having a code of conduct, a moderation team that is active whenever it needs to be. Luckily, that's not often, but sometimes it is necessary and good that it exists. There's a focus on great documentation, great tooling, and somehow making it easy to onboard newcomers. And well, we have mandatory code review for quality control purposes, but I think that might be the wrong perspective to look at. Code review for me is not about gatekeeping, but it's about teaching people the mathlib way of doing things, teaching them new tricks so they can formalize better, faster, more maintainable. So it is a teaching venue, which is also one of the reasons why investing lots of time into code review is great. And well, we do have continuous integration system with the not rocket science rule. So tests need to pass before you can measure code. If you have a master build that's broken, I would say your system is broken. You should do it differently. Yeah, we do have cache, which allows you to reuse build artifacts, a bit similar to Isabel sessions, perhaps. In the future, we'll also get that on projects, depending on the mathlib. We have a script that adds deprecations automatically whenever you rename lemons. And a few more nice tools. And this clicker doesn't work. Now it does. Yeah, we have linters. Linters are great. You should have more linters. What's your favorite linter name? Yeah, but they can do many things. They can check code style, they can check formatting. There is no auto formatter for Lean yet. I do hope that will change in the next year. I understand there are plans for that. I would love your formatter to become real, so I can focus not on formatting, but in the meantime, you can use linters to go a long way of enforcing some formatting issues. We have them for file naming conventions, say, enforce that no names have forbidden file names on Windows, to not give Windows users a bad time. Or perhaps naming conventions for functions. You can have linters for robustness, say non-terminal sims or simp lemmas, which are not in simp normal form, which are just a recipe to unhappiness in general. And deprecations are also implemented as a linter internally. So linters are great. We should have more linters. You can write more linters. If you want to write a linter, talk to me. Yeah, there's technical challenges with scaling mathlib. I'll mostly skip over this, but you want a fast core system, and you want the system to get better so it can keep up with the growing body of Lean code. Then you need to keep all of mathlib up with core changes, which is a monumental task, and I'm extremely glad that people pay to do this. Like, distributing this on volunteers would give me extreme pause. And then you want to speed up mathlib, because you can and because it makes everybody's life, including future you, well, better. You can do that by local profiling. We do have a continuous benchmarking and performance tracking infrastructure, so you can catch some unintentional regressions before they occur. And well, there's some substantial changes related to, for instance, unbundling type classes. You want to keep technical debt in check. I told you that already. And you also care about imports refactoring and imports reduction because it enables parallelism and also faster rebuilds. So all of this could easily be its own talk. This will not be today's talk because I want to tell you about something else, namely reviewing. So the first one is we can build tools to help reviewers to give them context they might want to know. Like if a pull request renames lemmas, if a pull request changes the import structure meaningfully, if a pull request adds technical debt, that is information a reviewer might just want to know. So whenever you open a pull request, there's a tool that there's a workflow that runs, computes these changes and posts a summary comment telling you all about these. And it's a sticky comment, so whenever the pull request is updated, the comment is updated accordingly. Yeah, that's a small feature that I really like is a better integration between GitHub and Zulip. So when somebody mentions a pull request on Zulip, and the pull request has already been merged, like this bot adds a corresponding emoji reaction. So you don't need to click on the pull request link just to see, did this get merged already, or is it waiting for somebody to do anything? Like small things, but they add up. Yeah, and perhaps finally, or firstly, if you have a new pull request, you want to find a good reviewer. So at first you want to know what kind of area is it in. Like if you have an algebra pull request, an algebra should look at it. At least if you want to find, is that good design, are things appropriate in general, and so on. So we do have an automatic labeling system that looks at the files, the pull request modifiers, and then labels the pull request accordingly. And the second step, we have an automatic reviewer suggestion system. So basically, for each reviewer, we collect their areas of interest and expertise, and then use that to suggest candidate reviewers for each pull request based on their expertise and taking, well, capacity into account. So you can opt out of being on this review rotation. And you can also say you can only review this many PRs. And if you're not on the rotation or if you're already at maximum capacity, you will not get assigned that pull request. But otherwise, you'll be asked to take a look and for either say, okay, I can handle this myself, or perhaps I can find somebody else. I can also just unassign myself if the bot did something stupid, because I mean, it's impossible to get an automated system to be perfect in every case. So it's a random assignment in general, but it's taking capacity into account. So if you're already high at your review capacity, you're less likely to get assigned a pull request first. Like people at lower capacity will be chosen with higher capability. And all of that, I mean, it's a good first guess. It's not meant to be a final guess. You're free to reassign. You're free to steal reviews and say, I'm interested in this PR. I volunteer to oversee it getting over the line. Yeah, we've been playing with that for 3 months now, and I think it works quite well because you can already see that it avoids diffusion of responsibility. Otherwise, it's easy for a pull request that people kind of like, but nobody is absolutely psyched to just jump in and say, I'll take it. But if you're assigned a pull request, you feel at least responsible for doing something about it. And in the worst case, be it asking, I'm not sure about this pull request, should we accept it at all? But you might not have started this discussion in the first place if you didn't feel the push to do something about it. Yeah, so there is a bit of reviewing statistics. So at the moment, we have 424 pull requests awaiting review, or at least there were the numbers yesterday evening. Yeah, some of them are quite new. Some of them are a bit of a backlog. But there's also this number in the middle, which is pull requests which are not assigned, but have been without activity long enough that the algorithm would kick in. And this is interesting because it highlights existing issues, such as an area where we don't have enough reviewers yet. So we need to recruit more reviewers, or perhaps we need to find reviewers to help in other areas. So say all the reviewers for my particular area can focus more on this one.
Michael, maybe you should tell people how many reviewers there are and how many maintainers.
That's on my next slide.
Okay.
Yes, we do have a group of maintainers. We do have a group of reviewers. We have approximately 50 reviewers right now. I will perhaps tell you this right now. So there's many of them, but that's for all areas of mathematics. So you perhaps have, I think, 10 reviewers for algebra or something. But then if you're an algebra reviewer, perhaps you're also an algebraic geometry and you also review algebraic geometry. So if say more algebraic geometry is reviewed, and you can focus more on reviewing algebra. So you do have these spillover effects. Yeah, so missing reviewers in this area or in other areas, but also unclear labeling. So there is a label for data PRs, which is really broad, which is why you don't have many reviewers. But sometimes files are under this data area and they should just be moved somewhere else. So that's an opportunity to just move them. So yeah, I think it's a great learning opportunity at the moment where I think at the stage where we're trying to get to the bottom of what's missing here, which files need to be moved, where do we need to improve our labeling, which is, I think, good and what should happen. Yeah, I mean, the other one is like these assigned pull requests that have not been reviewed recently. I think one of the things we need is just a triage team that then friendly asks the reviewers, hey, do you have time to review this? It's okay if not, but then let's find somebody else. And I've been doing that for a bit, but I mean, I have too many other things I want to do. So what we really need is a regular team that does it on an institutional basis. So, yeah, we also want to scale reviews. It doesn't help if we have a nice tool that assigns people, but other people assigned are too busy. So the good news is everyone can review. You can review, you can review, and you can also review. Don't be shy. Yeah, we even have some guidelines like what things to look out for, but even if you just like look at one tiny aspect and point out something useful, that's useful because then another reviewer doesn't need to say the same thing again. Yeah, we do have a two-tier system. So the final line are maintainers, which is a bit like the editors for the AFP or journal editors. So they have the final say and can say, yes, we merged this. And currently there's 26 of them. But then we also have a reviewers group, which are like every maintainer is a reviewer, but there's also reviewers which are not maintainers. And there's, well, twice as many reviewers as maintainers. And they're experienced community members who have shown that they can provide useful feedback. And when a reviewer says, yes, this looks good to me, they maintainer merge it, so to say, as opposed to fully merging it. And then there's a direct notification to the maintainers who then look at this more promptly because in practice, that means like it's mostly good to just need some final look. And like often that leads to being them approved really quickly, or there's perhaps one or two small things. And sometimes it also means, okay, we need to rediscuss this more broadly. Yeah, as you would expect, I guess. So I did crunch some numbers here a while ago. So the system really helps that about 1 in 3 pull requests that gets merged got maintainer merged before. And this does not count those pull requests that are so easy that a maintainer looks at them directly and says, we take it without any feedback. It also does not count pull requests where reviewers provide some review and then the maintainer gives the final say because before a reviewer maintainer merges it. So I think the actual number of spreading review helps is even higher. Yeah, so make it a team sport, share the load. It's much more fun this way. And well, don't forget to make it enjoyable. Like we did have this tradition of review parties online where you just meet and say review lots of geometry PRs. Or we had triage meetings where we looked at pull requests that were unreviewed for a long time and tried to make progress. I also really dearly hope there'll be a reviewing retreat in January where some experienced reviewers and perhaps not so experienced reviewers or community members who want to become reviewers get together and learn how to review better, but also just have fun reviewing together. So my understanding is that there's still pending funding application approval, but I would be extremely happy if this happens. I mean, reviewing is, so to say, this communal thing we want to do. You might make it a communal thing, you might make it fun. Okay, so we have 10 more minutes, so let's talk about editorial tooling. So mathlib has a review bottleneck, as I said, so we need more reviewers, but we also need better tooling to discover which pull requests can I review. If I have 2,000 of them, looking through every single one of them just takes too long, and then the hour I have for reviewing is already gone. That's no good. You want to assign responsibility, so there's one designated reviewer per pull request. And you want to have some triage and tracking to make sure that no pull request is left behind. And this left behind can both mean like it's just forgotten about, but also there's perhaps an infrastructure issue after the pull request was merged, but then, so it did not get merged, but like it falls through the cracks otherwise. Like there's a very there are various stages where pull requests can get stuck. And if you build custom tooling to tell you about each of them, you can beware. So mathlib means editorial tooling. And well, you can go and build it. So we want to keep track of all open pull requests and then ensure that each of them gets a timely response. So yeah, we want to track the review queue and allow, say, filtering by subject area, for instance. We want to make sure that no pull request is left behind. We want to have automatic reviewer assignment. But then on a technical level, like all of these you could do mostly using GitHub's built-in features, but the last two things you really cannot. Because GitHub has this information, a pull request was last updated on that time, but that's both too coarse and too fine. And it's too coarse because it misses some updates. Like if I force push to a pull request, that last updated date does not get reset, for instance, which might be important. But it's also like overzealous, because if there's just a merge conflict and I fix the merge conflict, that counts as an update, even though there was no real user interaction. If I edit your pull request description to fix a typo, that counts as an update, which is no meaningful update. So we need a notion of when was the last meaningful update. And perhaps also we want to track how long has this pull request been waiting for review overall, summing up all these intervals, which are perhaps separated just by fixing a merge conflict. So this is really, we need some custom tooling to compute this information for us. And then when we build custom tooling, we can realize we have different target groups that want different information. So you might as well build that into a system. And well, that's what we have done. So last year in July, Johan and Cormelin built this prototype, posted about on Zilip and said, well, I hope you find this useful and help is welcome. I somehow was really excited about this, had a bit of time. So I went ahead and implemented some of my ideas and then some more, and about 5,000 lines of code later, we have this. So this here is the big front page. And you can see there's already like one page just for the review queue. There's one for the maintainers that includes all of them that got reviewer approved, but not maintainer approved yet. There's one for triage, which shows you all kinds of triage-related metrics, such as pull requests, which are unassigned but haven't seen recent activities. So you can look at those, or perhaps pull requests that are assigned but without recent activity. We also have a big dependency graphs of pull requests that depend on each other. Yeah, but you can also just see all of them if you like that, or perhaps see why is my pull request not in the review queue? What's missing here? Yeah, so the core of this is a lot of dashboards which look a bit like this. So you have some key information here, such as the labels it has or the size of the overall div. Can be useful information. If you know a pull request just adds 2 lines, you might say I might as well review it quickly if it's 1,000 lines. Perhaps you want to set aside some more time. If it's assigned, when it was last updated, that's the GitHub last update. But then there's also when was the last real update, like when did the pull request last switch from waiting on author to waiting on review or having a merge conflict and so on. And that's a total time review. Yeah, so every time you implement a new metric, you see some surprising things. So this screenshot is a few months old, and you find out, okay, there are pull requests that have been in review for several months. Oh, let's take a look at them soon. Yeah, I mean, you can sort by all of these, and this sorting is semantic. So for instance, if you sort by div size, this is not an alphabetical sorting, but a numerical sorting, and the sorting by the total count of lines that you modified. Here, when you're sorting, this is sorting by the date, this is the total time duration converted to seconds, and so on. And you also have the search feature here, so you can search for authors and assignees specifically, but also just for any expression that occurs in this big table. So you can search for PRs by the label, by the title, but also by words in the PR description, or by the files they modify. Like, because it's custom tooling, we can make this as useful as we want to. And we could make it even more useful. So if you need a feature, talk to me and we can implement it. Or I can tell you it's already implemented, we have it for you. So on a technical level, This is statically generated web page. We have a Python script that generates an HTML page, and then most of the dynamicism is using JavaScript. So these dashboards here are jQuery data tables. So there's some HTML code for the table, and then we'll use JavaScript to sort things or to filter, which works really well. And one of the advantages of being a static web page is that filtering or searching is near instant. If you do that on GitHub, perhaps you take 30 seconds. Here you don't. Downside is you need to update, rebuild the web page manually, which currently happens every 15 minutes. Yeah, so that's this front-end part that somehow, given information about all the pull requests, generates a web page for you. And that's the back-end part that downloads the metadata for all open pull requests on mathlib. And so it regularly asks, are there any pull requests that got updated metadata? And if the answer is yes, for each of the updated one, fetches the new metadata, and then it generates the web page accordingly. Yeah, it's about, well, 4,500 lines of Python scripts for the web page generation, but also the metadata download, checking for data integrity, and so on. And 1,000 lines of shell scripts, GraphQL schemes to describe which metadata you want, etc. Yeah. I mean, so far the description perhaps sounds easy. It turns out things are much harder than you think, especially if you're not a computer scientist and you have to learn other things the hard way, such as like these web page updated run as scheduled regularly using GitHub Actions. So you can run them at most every 5 minutes at a built-in limitation, but there's no guarantee how often they run. The intervals between them might get arbitrarily large, but they might also get quite short. So you both have to deal with the fact that your last update was perhaps some while ago and you might to catch up on things, and also that you don't want your workflows to run concurrently, or at least you make them robust against that. Yeah, sometimes you need to prepare with outliers. Some pull requests have 40,000 commits because of some Git mishap. You don't want to download metadata for all of them every time because you just get a timeout. So we have about 1% of all the pull requests that just have a reduced set of metadata because of these kind of issues. There's pagination in some of the APIs that you need to deal with. Yeah, GitHub's last update is incomplete, like it doesn't always update when you think it updates. So you can't rely just on that to figure out if you really have the updated information. Yeah, I mean, everything in distributed systems is hard, so expect network errors, intermittent failures, push races, everything and so on. And well, one of the fun things is when we compare the results on our web page to the GitHub results, that sometimes we were more updated than GitHub because like searching for pull requests on GitHub also has a time lag, which sometimes not features. Yeah, so distributed systems are hard, but if you spend enough time on it, you can do okay. And of course, you should be really happy if you have some actual computer scientists that can help out. So Brian, whom I mentioned on the first slide, is now helping out, and he has much more CS background than I have, so I'm extremely happy about this. Yeah, so next steps, faster updates. Like right now, we have a latency of around 15 minutes. I would love for I update a pull request and the entry on the dashboard is updated within the next minute, which is technically possible, just needs sufficient amounts of engineering to do it. I know what needs to be done, but I mean, doing that robustly is a challenge. We could have closer integration with Zulip, such as the weekly post, like these pull requests are assigned, but haven't been touched in a while. Let's at least consciously think about that. I think we need a triage team to manually do all the follow-up, and should make this institutional as opposed to people doing this next to their day jobs where they're supposed to write papers and give talks. All tooling requires regular maintenance, and mathlib needs more reviewers. So this might look very grim and a bit like your slide, but Lean is a bit lucky that somebody came around with a large bag of cash, and now there's the mathlib initiative that hopefully has some funding for both developing the tooling and for paying people to do reviews, which I think is extremely great and extremely important. Yeah, so in summary, it takes a village to build a big library, especially if you want it to be useful. If you want to go far, go together. Secondly, empower and be willing to mentor new contributors. You will be surprised what they can do if you let them and teach them what they can do. Open source is great here. It allows just for serendipitous contributions. build tooling to automate as much as you can, because all work the tooling does, you don't have to do. Custom tooling takes effort, but it's worth doing. And well, all of tooling and maintenance needs funding to be worth it in the long term. So that's what I'm going to tell you. I hope you could take away some interesting things. Thanks for listening.
Thanks, Michael. Any questions? Yes.
How much was mathlib, or more particularly like the mathlib maintenance team, able to learn from all the efforts, like for instance, the AFP efforts that have been going on?
That's a great question. Since I'm not a mathlib maintainer, I don't know what the maintainers learned from it.
So
perhaps you can say more, Patrick.
I think the system is really very different from the AFP. I mean, you've heard what Manuel explained, and you cannot compare. I mean, at the beginning of his talk, Michael said there are 3 entries submission per week and 30 PRs to mathlib per week, but those are completely different numbers. I mean, the pull request in mathlib can be just fixing a typo in some documentation, or they can be adding 1,000 line or anywhere in between. So it's very hard to compare. The system is very different. It's also very different from for instance, MathComp, the mathematical component library of Rock. It was a much smaller team with clear experts from the beginning, and not 500 contributors like mathlib or the AFP. So it's very, very hard to compare. So probably we should still learn more from each other. It's very hard to learn from other communities, but also because the settings are very, very different.
Yeah, I should perhaps add, I mean, this reviewing issue is in a sense specific to mathlib because we have a particular style of reviewing. Like if your reviewing standards are lower, it becomes less of an issue.
Yeah, and the fact that everything is in the same library is also a big difference, and it's yeah, and also about those 2,000 open pull requests, we also have this probably bad habit of basically never closing any pull request. So if a pull request is abandoned, the argument is something like, yeah, but if someone wants to do this thing and searches for open pull requests to see if someone is already doing it or could take inspiration, so just let's keep it open just in case. And so the number of actual pull requests that may be merged one day is not 2,000. I don't know if anyone did statistic on it.
This dashboard has some similar statistics. So at the moment, we have about 400 pull requests that are on the review queue. And then I think perhaps another 600 that are waiting on the author to address review comments or that are blocked on an existing pull request. So you want to merge the blocking pull request first, and then it'll get in the review queue. So like half of these will probably merge for sure. And for the other half, I mean, it's not so clear. Like sometimes it would be nice for them to merge, but then the author also needs to like dust them off, and it might not be highest priority.
Yes.
So maybe as a follow-up, I was kind of wondering, like you talked a lot about reviewing, but I was really wondering, what do the pull requests look like? Like, are they short? Are they long? Who are the people who make them? Are they like, is the typical thing like someone dumps a whole paper formalization on you and then like it's a multiple thousand lines? Is it like typically more like a typo fixing? Like, what do they look like?
Yeah, great question. Thanks for asking. So I've put here a slide that shows, well, some pull requests. So you see, for instance, the number of lines. So the typical pull request is short, and this is intentional. If I have 3,000 lines of code, reviewing that properly in one sitting just takes ages. So it's much more efficient to split it into bite-sized pieces. So usually, like I would say, if you have a pull request of 500 lines, it's already on the large end, and like sometimes you need it to be that large, but if you can split it into 2 pull requests of 300 lines, that will usually get your pull request reviewed faster. So I would say that's more of a typical distribution of length. I mean, there's also some statistics along the type of pull request. So mathlib has a statistics page And they do have the statistics now. So about half of the pull requests are feature pull requests, so they add some new code, like a new theorem, or they generalize a theorem in a meaningful way. And half of them are chores, like renaming this lemma to match the naming convention that we have because somebody made a slip, but perhaps it was done in the past when we didn't agree on this naming convention this way, or fixing a typo, or improving documentation, and so on. So I would say half of it is like new features and half of it is maintenance, cleaning things up.
Who are the people typically? Like, what's the kind of balance between people very integrated in the community versus people doing like one pull request and then never appearing again?
I would say the mathlib community is very broad. Like you have expert users, but you also have absolute beginners. Like you have mathematicians, computer scientists, people with a physics background from high school or university, have tenured academics or in industry. So you really have like very diverse backgrounds and groups. And you also have very, I would say the contribution frequency also varies. Like some people just submit one pull request, others just fix 5 typos and are happy to have contributed 5 typos, and others do several hundreds of them. So it's like all of that is there.
Sylvie?
I have a question about editors and reviewers. Do you have the notion of conflict of interest? So can you review yourself or things like that?
So I guess technically, so I mean, GitHub enforces that you cannot merge your own code, I think. So that's one thing. I mean, the other thing is that, so to say, the community is small enough that we could still check like people behave reasonably well. Like if Patrick and I were to author a pull request together, I make a pull request and Patrick as a maintainer would merge it, that would look really bad and people would notice and complain, and that works. So in practice, I would say this is not an issue. I mean, what happens is that we realize, okay, I'm biased, I co-authored this, or I gave significant input, and then a maintainer says, this looks good to me, but can somebody else please take a final look? And that is very common. Like a maintainer can also maintain a merge saying, this looks good to me, but please somebody else also approve.
So there is no written rule, but it's expected to test someone.
And another very common case is maintainers not merging anything done by their PhD students, for instance.
Yeah.
That's reasonable.
But great question, thank you.
Maybe one last question, yes?
It seems that I really like the automatic assignment thing, but it seems like we've traded a bunch of stale unassigned PRs for many stale assigned PRs. Do you have an idea how to fix this?
So I would say this is an improvement.
Now there's someone to blame.
I mean, if we have some notion of this person is responsible, and then we can talk about accountability, about signaling, I actually don't have time to review. That's much better than if there's some diffuse responsibility that doesn't work. That's one thing. And I mean, I think we can definitely get better at signaling, okay, I actually don't have time to review many pull requests right now, so please don't assign me too many. Like we're still learning how to do that well. We can bug like signed reviewers now personally and ask them. So I do think it's a better place to be in, but there's room for improvement. And that might be a triage team systematically looking at reviewers who have many assigned PRs who don't get around to doing as many PRs, and asking if they want to be on the rotation or at a smaller capacity, just well, to manage expectations for everyone. It's okay to not review as much as your neighbor does. I mean, this is not a contest of who does the most. We don't need that toxic comparisons. But I think it's good to manage expectations well.
Yeah, and I think we can say also that since the beginning of the Lean FRO, there are already some people paid to do maintenance work for mathlib, and now the mathlib initiative is starting, and there will be more people paid to do reviewing and maintenance. We are clearly reaching the limits of what you can do with a team of people who are not paid for this and won't get any credit for it. So we are transitioning towards a more professional model. Hopefully it will improve things. And now we have a break until 11. I guess there is some coffee somewhere.
Yes.
There should be coffee. And so thanks, Michael, again.